In number 3, we are being asked to find we're given the arc length of a circle and the area, and we want to determine the radius and the central angle and the area of the whole circle. So I'm first of all just going to draw a diagram here. I have an arc length of 16 centimeters. I don't know how accurate this is. So that's 16 centimeters. And we have an area of 124 centimeters squared. Okay, so this is what I'm looking at, and I have to determine the radius and central angle, central angle, and the area of the whole circle. So I want to be able to I can use a formula for finding out the radius from the area, because the area formula looks like this: theta r squared is equal to the sector area. And we get this formula from our theta over 2 pi, so the part area is equal to the sector area over pi r squared. Some things cancel, sorry, it's going to be theta r squared over 2. Some things cancel out, the pi's cancel out. So the r squared can be moved to the other side, so we end up with theta r squared over 2 is equal to the sector area. So this is actually a formula we could use, and we'll use this one to solve for the, in this case here, we can't use this one to find the radius, because both the theta and the r are unknown. So we're going to do it this way. So we're going to have set up our fraction. 16 centimeters is part arc over the whole circumference is equal to the part area over the whole area. And when we do this, we only end up with one variable, which is our r. Okay, so I'm going to cancel the pi r on this side, the pi r on this side, and we end up with one variable r. So we do 16 divided by 2 is 8, and then we're going to bring the r to this side. That's equal to 124. We can solve for r by dividing both sides by 8. So 124 divided by 8 gives us a radius of 15.5. So although I did come up with a sector area formula, the sector area formula would have been difficult to use because we don't know the radius or the angle, and we just know the sector area, so we have two unknowns here. So to get around this, we did the part arc over the whole circumference divided by the part area over the whole area, and by setting that equivalent fraction up, we end up with just the radius as a variable to solve for. So there's my radius. I can work out my central angle now, because I know that the central angle theta over 2 pi is equal to 16. I'm going to use the arc length of part arc over 2 pi times the radius. The 2 pi's cancel out, so the angle is equal to 16 over 15.5, and that works out to be an angle of 1.03 radians. Okay, so there's my angle, I've got my radius, and then the area of the whole circle is just going to be pi r squared. So pi times, so the area is equal to pi times r squared. So pi times 15.5 squared gives us 754.77 centimeters squared.